Hello again. Video number 3 of the RP2040. Just continuing on. So this is where I left off last time, and let's see. We've got the power section. We've got the micro sitting here. We've got a couple of wires connected. Oh, I could add these the USB connections. Those have to go in also, and they actually connect pretty close by. So let me just get those figured out here. So if I come over here, duplicate that. This is DP, so that'll just go right here. Click that one. Command D. Again, I'm on a Mac. That'll be DM. A couple wires to make those connect. Now there's a ton of power wires that connect, and we do really need to connect them all at once. Let's see here. I think we can do a bunch of them. I got 3.3 volts that goes to. Let me just put those in here. Here's a 3.3 volt symbol up here. Let me just grab that. I'll just duplicate that. I want to set it out far enough that that it doesn't, I can get labels in there. So I'll set it there. And the obvious first one is right here. Next one on this side is IO VDD, which is this guy. Oh, pin 10 also. I've got my notes down here beside me because I've done this a few times. But you can just get the schematic of the Pico and it'll show you which ones need to connect. Okay, so I've got those three connected on this side. And you know, this run pin actually will need a resistor and a pull-up resistor to plus 3.3. Let me just grab that while I'm at it here. Let me just grab a resistor. Since I've already put the packages on, they should all be pretty straightforward. So I'm just going to put, I want to put that right about there. Now it doesn't want to be 27 ohms. So if I put my mouse on it, type an E key, I can make this something like 10K. Okay, so we need some parts, some traces on this. They go from here to here. Okay, so I've got that. And we've got some ground lines that need to go in. Let me just grab a ground. Command D for duplicate. And I need a ground on, it looks like pin 19 needs to be grounded. Is that the only one over there? That appears to be. So I'm going to actually set it right there, since I don't have any tags getting in my way. Click the... Okay. That should handle everything over here. Now, I mean, obviously, I've got all these other things that I need to connect in that'll do who knows what, you know. There's some debugging pins. I'll connect those up yet in this episode. Okay, we've got some ground pins. So I need another ground. There's a ground there. Let me just grab one of these. And, I mean, those traces are going to come out, so I want to get this up just a little higher. So I can just... Okay, so there's that ground. And there's a bunch of pins that need to connect down below here. And again, I want to leave enough room for labels and stuff. And here's a VDD. That's another VDD and IO VDD. Those are actually slightly different. VDD is actually a 1.1 volt system. So, but it's regulated by the processor. The IO VDD is going to be the 3.3. So let me grab that. I keep debating on how I want to do this. Let me connect a couple of these other traces that need to be connected. The VDD, as I said, is the 1.1 volt. Let me grab that, and I'm going to run it out a little ways. And I'm going to come down to, I guess it goes to pin 45. This is our regulator that the VReg out is the 1.1 volt regulator, and I need to run that clear to the other side of the device also. So I'm just going to put a tag on it, and so it gets labeled as such. I want to power. This is actually 1.1 volt, so I'll actually label it that and put a trace on it. And then that goes also to clear over to pin 23. So what I want to do is duplicate that, and let me just slide over here. I feel like I'm working on a really small screen here, so that causes me grief. Okay, so there's that. Okay, so there's that part. There's my 1.1 volt. That should connect automatically, so that should be easy enough to deal with. And then, okay. No, but that's going to need a capacitor to ground. So I need a cap. Let me just zoom out a little bit. Grab a cap. It doesn't matter which one, because they're all right now going to be 0805s. So I grab that, and I'm going to put it just right there. And that's going to be bigger. I'm going to make that a 10 microfarad because as big as you can put on there. And I've got that part, so that's kind of why I want to do it. Let's see here. And I want 10 microfarad. Okay. And then I need traces on that. So that one's going to come up to here. The other side of that goes to ground. Duplicate that. Set it there. Okay, so that's ground. Notice as we go along that unconnected pins have got the little circles on them. And the other, once they're connected, the circles go away. Kind of keep that in mind as you're going, so to make sure that you don't lose track of something. Now I need a bunch of things connected to 3.3, so I'm going to bring out some traces for that. Here's the IO VDD on pin 49. That comes out, and that actually connects to pin 48 also, so we'll get to that, but we'll connect it out to here. We'll bring it on down, and that goes to several pins actually. So it goes to, that's the input to the regulator. Pin 48 connects to this also, so I could just bring that out. Okay, then let me shrink this up a little farther. We've got another IO VDD that has to connect. So all these things are still 3.3, and then clear down on pin 33. We got another IO VDD. So I want to take this and bring it all the way down to 33. Now these are all 3.3 volts. So I can just let me just zoom out and grab one. Duplicate. And if I just stuff this in, I got to keep down a little bit low because I know I've got another part that goes there. And then I can just connect this into here. Now, we're going to want a cap on this too. And so let's just, and I'm going to probably make it a 10 microfarad. So I'm just going to stick it in here. And I need to the ground, so I'm going to stick that in here too. So now I can line those up. Okay, so I've got the 3.3 volts to ground. So this is all just stuff that we need to make the machine run. So we're not even to what we want it to do yet. Now I've got the ADC AVDD. That's the power for the ADD converter. and you kind of want it to be a little bit quieter than the rest of it. And one of the ways they recommend to make that quieter is just a simple resistor followed by a capacitor. So, but they use a off the 3.3 volt line. They're using a 100 ohm resistor. So let me just go get a resistor. It's going to be the wrong one. We'll fix it. And let me hit the R key to rotate it so it's actually vertical. And let me put it just about there. I need 3.3 again. You know, just to make it a little better looking, I'm going to put it right there. So those connect together. Oh, I need to change the value of this guy. The resistor should be 100 ohms. I'm just going by their suggested design. And then, you know, we're going to put another 10 microfarad cap to ground. So I'm going to put that. And this is the line it connects to, so I'm going to put it just slightly below that. And then we got the ground again. And we can just put that there. Okay, so that's still clicked, so we can just go to this, this to this, and then this will come out here to that. Okay, so now I've got this is actually a power input. It's going to give us a warning message on that, and we'll fix that in a minute. I've got a gazillion unconnected I/O lines, and anything else. I got the memory chip to add yet. We still have to do that. And I've got the programmer pins, the debugging pins. That's a connector that connect into SW clock, SWDIO. So let me grab those. So I'm going to add a part, and I want connector generic 3-pin. That looks good. And I'm going to rotate it. Let's see. I guess I want the pin 1 on top. I want it to match what. Oh, this will be fine. There's a connector, and I need a label. One of the pins is ground. In fact, they ground the middle pin. So let me just ground the middle pin. Copy. Oops. Duplicate that. Okay, so I want that there. There's that. Pin 1 I want to be SW clock. So I'm going to come over here and pick a flag. SWCLK. Okay, so that's going to be pin 1. And then I can wire it in. And this one actually needs to, I'm going to duplicate that while I'm still working on that. Rotate it twice. And here's the SW clock it needs to connect to. So I'm just going to take it and put it right here. I can see these labels are going to be in my way when I put the other part in. So let me fix that while I can reach them easy. Let me just say move. And I'm going to just move that down here and click that label, say move, and put that there. And I need a line. Okay, so now I want another label, and this is going to be SWDIO. And I'm going to put that there. I'm going to wire it in, and I'm going to duplicate that label, hit the R key twice, drop it right there, and then put the wires on it. Okay, that's the debugging connector. Let me run annotate real quick here, so everything has numbers on it. No errors, no warnings, good. But now it says J2. This and the resistors are all labeled and all that sort of stuff. Okay. We are still missing the memory chip. So this is probably where something's going to be interesting. So I want to find, and the part that I happen to have is a W25 Q32, and I've got the SS part here, so I'm just going to pick that and just say OK. So that just gives me the part. That's how very convenient. And I just need enough room over here for some labels and stuff that'll go on this. Okay, I mean, I can click the annotate to give it a number. That is going to be U3. Okay, so we need powers and grounds. The 3.3 volt device. So let me just hit the escape key to get back to a normal mode, and then put the cursor there. There's 3.3 volts. There's a ground. I should probably have a cap. Oh, come on now. Cursor on the part and Command D. Okay, there we go. I want it just over far enough. Now let me zoom back into this again. Let me throw on some wires. So that goes to there. This goes to there. This goes to here. Some people draw their schematics with that, with the caps all located that are between power and ground in one spot. I put them on the schematic near where they need to go, just because I know that needs to be near that particular part. Okay, so now I need labels on these specific things. So let me create some labels for them. This is IO0, IO1. What are the other ones? IO2 and IO3. Well, let's just call them that. IO0. Notice O and 0, they're looking an awful lot alike. Okay, let me IO1, IO2, IO3. Okay. Now, these go to the micro, and they match the SD0 through SD3, and they're not all in nice spots, but that's okay. We're just going to put them right there. So let me just duplicate them, and let me hit the escape key a few times till the cursor goes back to normal. I just want to duplicate that guy. IO0, there's the SD0. We'll just put it right there. Let me click that guy again. Command D. Oh, it's confused. Let me hit the escape. Command D. Here's number 1. SD1 is right here. Command D. IO2. SD2. Let's put that there. SD3 is down here. So let me come over here. Command D. Get S. That's still 2. IO3, SD3. Okay. Now I've got a couple more parts that have to go onto this, wires. I need the clock line, and this is for the memory clock. So I want to distinguish that from the other. Let me put a tag on it here. And this is going to be MCLK for memory clock. That's okay. And the tag's going the wrong way. Let me hit the R key twice, put it there, and wire that in. Oh, let me just wire these while I'm here. Now they do something really strange on this particular processor to make things work. It's got this button that you hold when you boot that forces it into a special mode. And they actually wired it in kind of strange, but you know, so we just have to copy what they did. So I need another resistor, and it happens to be 10K, so I'll grab that one because it's 10K. And I'll put it right there. And I need another, so this is going to be kind of a pull-up. So I'm going to go from here to here, off the chip select line to here. Okay. Now from there I need a smaller resistor. I'm just copying their design, but I'm going to say, let's duplicate that, and I'm going to put it right here. But it needs to be a 1K. So I'm just going to change this 10K to 1K. I'm going to wire this side in. And I need a switch to ground. This is the button to ground. So let me... So where did they put it? Let's see. Switch. Coded dip. Push. Ah, that looks good. Okay, so I got the button. And we'll just put it right there. And then on the other side of the button, it needs to be grounded. Duplicate the ground, so that. Okay, so now I can wire these parts in. Now, this memory chip select also has to go to the processor, and it goes to the SS line that's actually right down over here. But just to keep things consistent, I'm going to put a tag on it. And I'm going to say memory chip select, MCS. Rotate it. And I'm going to put it right there. And I'm going to wire it in. And then I'm going to hit the escape key till the cursor goes back to normal. Duplicate that. Rotate it twice. Drop it there. Okay. So now, that looks about right. Let's get some wires on this thing. No, my clock line's not there yet. Okay, well, my clock is M clock. Hit the escape till the cursor goes back to normal. Command D on the clock line thing. Rotate twice. And we'll put it right there. Okay. I think that's about everything. I think that should technically run. Let's put an LED on it just for completeness, because I mean, past this point, it's your design, not what is needed. But really, you kind of need an LED in there to make things go, and we have an LED. So let me just throw an LED off of GPIO 0 or something like that. We may change it in the future. But just LED 0 is what I'll call it. Rotate twice, and we're going to set it right there. Connect that in. Hit the escape key so that goes away. Command D, copy that label. I've got an LED right there. Let me rotate twice. Let me put it right there. Now it needs a resistor. So let me just grab this one here. No. Command D. I didn't give myself enough room. Okay, that's okay. Just the M key when your mouse is on it. That'll get us there. And the resistor should be a 1K. Let me put the mouse there. E 1K, and draw some lines. And this actually has to go to ground. Let me grab a ground. Okay, so we now have a working, should work type system. Let me annotate everything to make sure it's all got numbers, all those extra resistors that we've added. Complete. So now we need to go back and we need to look at the packages to make sure that we got everything correct in there. And up here is the footprint assignment tool. Let's go ahead and run that. We've got a couple of things that are not connected. Connector. And this is going to be connector. Oh, geez, got all these options here. Pin headers. That sounds good. I'm going to do 10th inch pin header for this is the debugging connector. 2.54, that's the 10th of a millimeter, and I only need 1 by 3 and vertical. 1 by 3 horizontal, 1 by 3 vertical. So I want that one. Switch, push button. I've got a note of which button I've got in my stock. I need button switch. Okay, button switch, surface mount, and I'm actually going to run the SPSK. Or, okay, let's see, dip SPST_CK. The CKRS28G05A3. I went and looked at the specs to find out one that had the dimensions that I have. It's a surface mount switch. They're not very big. Okay, so I can say okay. So that should be everything. Let's run the design rule check, and it's going to give me a gazillion errors. Okay. Pin not connected. I got a whole bunch of those. Power pins not driven by any output pins, not connected. Output pins not connected, not connected. Okay, let me close this. And let me just go ahead and do this for all these that are not connected. That I'll get rid of those symbols later, but I'm just telling them that's okay that they're not connected. We'll get rid of those symbols when we actually start adding things to it. Okay, we got them all. Let me run the design rule check again. Run. Pin not connected. What pin is not connected now? Oh, pin 4 on this guy. Okay. That's still selected, so that can take care of that one. Pin not connected, U1 pin 39, so I missed one. My message is in my way. 28's there. Aha, I missed. Okay. Okay, so now I should run. Okay. Unconnected, no connection flag. I clicked one too many times. Let me get rid of that. Okay. Run it again. Okay. Power pin not driven by any output power pins. This is common. This is when the schematic checker is really confused as to, is this something that we should be worried about or not? But it's like, this is an input power thing and I don't know what to do with it. So under powers, there's something called a power flag, PWR flag. And if I just take that and connect it to this trace, it's like, don't worry about it. We've got power here. Ooh, I better move that. I want to get over one. Okay, now we can draw that line. There's one of them. And let me run it again because I don't remember where the other one was. There's the other one. So if I just, again, do that with the power flag, let me move it out a bit so it doesn't get in my way. Run a trace. That's connected. And if I run the design rule check again, it's complaining about that. Power output and output are connected. It doesn't like the power flag there. I'll have to look into that. Okay. minor issue. We will resolve it shortly. Let me get rid of this stuff though. Okay, I'm going to end this video here and save my work. So the next video we start making modifications that make it our board rather than just the generic enough to make it run.